Hello guys, this is me solving the special right triangles exact answers problem. So what we have in here is what we call the special triangles. Those triangles are of two kinds. The one that has 45 degrees in each of the angles that are not the right angle. And the other case is when we have 30 and 60 degrees in the other two angles. So let's look at this. We know that the lengths of the sides of the triangle of the special cases are determined by this formula we have in here. They are not formulas. This is pretty easy to get from applying Pythagoras theorem to the cases. If we suppose one of the sides is of length x. All right, so let's see what we have in here. We have this case, right? We have this first special case. So let's see what we're given in that case. We are given 8 for the hypotenuse, and we're given b for the long side. We can call it that way. So let's see what we can do with that information. 2x will be 8, so 2x equals 8. That means that x equals 4 in this case, right? So we can use the other side because it says that b equals the square root of 3 times x, but we already know that x equals 4, so this will be the square root of 3 times 4. So that will be the answer for the first one. 4 times the square root of 3. Okay, let's see what we have in the other side, in the other case. We have a special right triangle, the one that has two angles of 45 degrees. And we're given this hypotenuse that is of length the square root of 2 times x. And we're given colors. I ran out of colors. This other side that is of length x. Okay, so we can get from the hypotenuse that 5 equals the square root of 2 times x, right? That means that x equals 5 divided by the square root of 2. And that information we can substitute in the other piece of information. It says that a equals x, and we already know that x equals 5 divided by the square root of 2. I just realized that my 5 sometimes seems to be a square root symbol, but I always put a little tail at the end of the square root, so you don't get confused by that. This is 5 divided by the square root of 2. Probably Alex will give us a good answer if we write it like that, like 5 divided by the square root of 2. I'm going to experiment a little bit and see what Alex says about this. Your answer is incorrect. For the first one, why is that? 4 times the square root of 3. Why? I don't know. I was hoping to get an incorrect one. Oh no, this is A. So yes, we have to simplify this somehow. And what we're going to do, that's why that's the reason why I was experimenting with this. We're going to multiply by 1. You know that multiplying by 1 does nothing. Everything is going to stay the same. But the strategy in here is that 1 will be the square root of 2 divided by the square root of 2. That equals 1, right? So when we multiply, like we always multiply fractions, numerator times denominator and denominator by denominator, we will get 5 times the square root of 2 divided by 2, right? Because below the square root of 2 times the square root of 2, that is the square root of 2 squared. The square gets cancelled with the square root, and we get only 2. So let me try that. Copy this one and paste it in here. Okay, now it is correct. So be careful with that part. You have to put the square root in the numerator using this kind of trick, right? And yeah, that's it. Thank you very much.